Okay, today we will discuss solids whose axis is parallel to both the reference plane. That is, the axis is parallel to both HP and VP. Suppose this is a solid. Okay. Now this solid is parallel. The axis of this solid is parallel to both HP and VP. We can have it like this, that this is HP and this is VP, and the solid is here. Axis passing through center of the solid is parallel to both HP as well as to VP. And how to draw it? Let us see. Now, if the axis is parallel to both HP and VP, and we cannot directly draw the images either here or here. So we need to draw the base first. The base needs to be drawn on a auxiliary plane, which is somewhere here. First you need to take the projection on the auxiliary plane. Okay. From the auxiliary plane we take back projection onto here. Let us see how. Suppose we have a hexagonal prism. You have a hexagonal prism, base side 30 mm, length let us have 60 mm. Okay, let us reduce it to 20 mm, and length be it's 60 mm. Axis parallel to HP and VP. So we need to draw the projection of this solid. So what do? The condition is like this. This is the VP, this is the HP. Here you have the solid. Axis is parallel to both VP as well as to HP. So what you need to draw? You cannot draw it directly, because for this type of solid you may never know what is this height, or while drawing it from the top you never know what is this width. So how will you draw it? So to draw it, you need to have an auxiliary plane somewhere here, which is known as AP. You first take the projection of the base on this plane, and from here we track the projection onto HP and VP. So we first draw the axis. X dash, and this axis y dash. Okay, now it is said that is a hexagonal prism, base side 20, length 60. So we are not concerned with length as of now, because first we are going to draw the base of the prism, that should be hexagon, and side is given 20. So we will draw this base. We'll capture this image of this base on this AP. This is the AP. This is VP. This is HP. So first you draw the prism here. So you can draw it anywhere. So let us draw it here. So this is your prism. Okay. So we have drawn the base. Now if you remember, here is one base and on the back side there is one base. So if you name this A, B, C, D, E, F, you can name this also. G, H, I, J, K, L. So A is, you are looking from this side, so A is on the top and G will be farther from you and will be named in the denominator. So first you have A, B, C, D, E, F, and we have the names of the back side, names of the other base on the denominator: G, H, I, J, K, L. Okay, so this is done. So you have drawn the base. Here you can show the dimension taking any one side. This is how much? This is 20. So this part is over. Now what we need? We need to draw the elevation of the pyramid, of the prism, and the plan of the prism. This is the side elevation basically. So you take the elevation of the, so we draw the elevation first, we take projection. Now these points A by G and F by L will coincide. B by H and E by K will again coincide, and C by I and D by J will coincide because these points are mutually collinear. You can draw this. So anywhere you draw a line first, very faintly. Then what is the length given? 60. The distance of say 60 mm. We draw the line again. So this part you need to darken. This is visible. Done. Now you have to name it. So this part, if you see A, this is F. You are looking the image from this side. Okay. So the naming will be A by, this is, first we will name one side, that is we are looking from this side. This is F, this is A. This will be F by A. This is E, this is B. E by B. This is D, this is C. D by C. All in dash. Okay. Again G and this is L. It will be L by G. Okay. Then this is K, H. K by H. And this is J, this is I. This is J by I. All in dashed. Okay. So you can draw the axis here. You need not have gap between these two lines. Now we will draw the plan of the object. For that you need to take projections from these various points. From this point comes a projection here. These 2 points will coincide. These 2 points will coincide, and you have one here. Simply at angle of 45 degree you bring it here. Using a 45 set square, the angle of 45 degree, you are bringing the projection down here, and again you are turning the projection somewhat like this. here you take the projection wherever it intersects. This is your solid. So now you may be able to name it. See, this is A, it is falling here. A, this is B, then C, then you have D, then you have E, and then you have F. You are looking it from the top. So these names will come first. It will be A by C. This will be F by D. Similarly, here you name it. It is G. Sorry, this one is G. Then G. Then you have H. This is H. G H. This is I. This is J. This is K. K. This is J by L. L by J. G by I. So, and one more thing, you have to draw the axis, the point of axis. Axis will be located on the center here. You have to bring in the axis point. This is the line of axis. Simply you need to draw the axis here. Here we provide a dimension, and here we provide a dimension. So this is the required projection. So we are done with axis parallel to both HP and VP. Thank you.